Hey, what's going on, smart people? Today we're going to be talking about torques and moments. So torque slash moment is a product. Oh crap! It's the product of force multiplied by the distance of perpendicular to the set point. So let's just say we have this lever right here, and we are applying this force at this part acted on the distance of r perpendicular to point O, then the torque of point O will equal to the force times r. That's pretty easy. Well, torques deal with rotations. So a torque is just a rotation at a point of a point. So when dealing with torque, we have to set a rotation, which one is negative, which one is positive. So let's just say clockwise rotations are positive and anti-clockwise are negative. Now, if for this problem right here, mass is equals to 100 grams, and let g equals to 10 meters per second squared, we need to find E, the effort force. How much is the effort force? So let's just first say that the sum of torque at point 0 it's equals to at point O is equals to 0 because there are no rotations, so it's in equilibrium. There's no rotation, but we do know that there is a torque of E and there's a torque of W right here. So since the distance between W and point O is 0.5 and the distance between E and point O is 1.5, we can say that sum of torque at point O is equals to torque 1 plus torque 2. Torque 1 being 0.5 and W, torque 2 being 1.5 and E. So sum of torque at point O is going to be equals to 0, which means that 0 equals to torque 1 plus torque 2, and 0 is going to be equal to torque 1, which is F1, force 1 times force 2, and force 1 is going to be the W times 0.5, add with torque 2, which is the force of E, times 1.5. And remember, E is negative because it's going this way, it's going anti-clockwise, and W is positive because it's going this way, it's going clockwise. So therefore 0 equals to W 0.5 minus E 0.15. So since W it's equals to weight, and weight equals to mass times gravity, and weight is equals to 100 times 10, therefore weight is equals to 1000. Therefore 0 equals to 1000 times 0.5 minus E times right here times 1.5. So now let's bring up here, let me just delete this part real quick. So now that we have 0 equals to that, use another pen, we can say that 1.5 E equals to 500, since 1000 multiplied by 1/2, which is 500, and therefore E equals to 500 over 1.5. Therefore E, put it in a calculator, will be 333 newtons. Okay, so before you guys, there is some special cases I need to talk to you about torques. So one being that force can apply at an angle, if you have torque applying at force applying at an angle, to find torque, you can't just use this force because it is not perpendicular to this perpendicular distance. Okay, so what you can do is that you can find vectors and find the perpendicular distance to that instead. And then after that, you can use trigonometry. Alright, so let me just show you what to do first. First, you can draw the FBD diagram of the system of forces. So O, that point is going to have that distance E, and then that force coming in like that at an angle theta, and then that force is going to have a line of action coming up like that, and then R is going to be the distance of that. So you can say this is 90 degrees, and theta, since this is theta, opposite of that is also theta. And thankfully, now that you see that, you can say, well, we can use trigonometry to find out the force and then the distance, and after that you can find the torque at point O, which is just this times by this, right? So torque at point O is just that force times by R. So let me show you. So torque at point O is force times by R, not force. It is not equals to force times by E. Okay, so how will we find R? R can be found by using trigonometry. So it is pretty easy actually. First of all, sine of theta is equals to R over E. Sorry, capital E. So if we say theta at this point, and then sine of theta is that opposite, okay, over hypotenuse, okay. Since this is a right angle triangle, that will be E will become hypotenuse. Then we can say R is equals to E times sine of theta. Therefore, torque is equals to E sine theta multiplied by the force. So that's a new way, a new formula you can use to find torque if you have an angle acting, a force acting on an angle. Now, another special case is that when you have a force applied at two fixed points. So how would that be different to other torques? So this will be different because once you have 20 newtons coming down like that, there will be a force, because every action has an equal and opposite reaction, okay? And there will be a force coming up like that called, let's just say there's a reaction force called R on the right, and then a reaction force called R on the left, and then you have to calculate all of the torques for that. So the net torque will be RL times distance, RR times distance, and 20 times distance. It wouldn't just be 20, okay? So torque 1 would be RL times 0 meters, because it's acting up the point. So torque 2 will be RR times 4 meters, because 1 plus 3 is 4 meters, and it is acting anti-clockwise. Therefore, we can say that it is negative as a whole. Torque 3 will be 20 times 1, which is 20 newtons. 20 newtons meters. By the way, the special units for torque is 20 newton meters. It's newton meters. So now that you have that, you can say, alright, let me switch your pen real quick. You can say sum of torque at point O positive equals to 0 0 will equal to torque 1 plus torque 2 plus torque 3 blah blah, which means it will equals to 0 minus 4R plus 20. So 0 is equals to 4RR is equals to 20. Therefore RR as a force will equals to 20 divided by 4, which is just 5 newtons. And to find RL, you can just say sum of force in the y direction equals to sum of force in the y direction equals to 5 plus RL, which is equal to 0 because there's no movement. So 5 plus RL, so therefore negative 5 equals to RL.